This is Chapter 6, Section 3, Conditions for Parallelograms. Your objective is to prove that a given quadrilateral is a parallelogram. Don't forget to write your essential question and use your DOK chart. Here are the first three theorems of this section. You need to tell if something is a parallelogram by using one of five things. These are the first three. So a quadrilateral with a pair of opposite sides and congruent sides is a parallelogram. Side B, C, and AD are parallel and they are also congruent, so that means this is a parallelogram. Another way you can tell if something is a parallelogram is if the opposite sides are congruent. So I have two pairs of opposite sides that are congruent, the same length. The third way is that if you have two quadrilaterals with opposite angles being congruent. So angle A is congruent to angle C and angle B is congruent to angle D. The fourth way you can tell if something is a parallelogram is if you have a quadrilateral with angles that are consecutive or supplementary. So angle B plus angle A equals 180 degrees and angle A plus angle D equal 180 degrees. If that's the case, then you know you have a parallelogram. The last one is if you have a quadrilateral with diagonals that bisect each other, then you know you have a parallelogram. So BD is bisected by CA, and CA is bisected by BD, which makes this a parallelogram. Here's our first example. We need to show that JKLM is a parallelogram for A being equal to 3 and B being equal to 9. Since we have A and B in each of our expressions, we're going to substitute them and see what the values are. So I have 15A minus 11. I'm going to substitute 3 for A. So that's 15 times 3 minus 11. And then the 15 times 3 take away 11 is going to give me 34. So JK is equal to 34. Now I'm going to do the same for 10A plus 4. And in place of A, I'm going to substitute the 3. So that gives me 10 times 3 plus 4. 10 times 3 gives me the 30, plus the 4 gives me 34. So that's LM is equal to 34. Now since JK and LM are the same distance, they're congruent. I need to check to see if the same can be said for KL and JM. So now I'm going to go with KL is equal to 5B plus 6. That should be lowercase b. So I have 5 times 9 plus 6. 5 times 9 plus 6 gives me 51. KL is equal to 51. Now I need to make sure the same can be said for JM. JM is 8B minus 21. That's 8 times 9. Take away 21. 8 times 9 minus 21 gives me 51. So JM is also 51. Because both pairs of opposite sides are congruent, then that means this is a parallelogram. Next example, we need to show that PQRS is a parallelogram for x being equal to 10 and y being equal to 6.5. I'm going to substitute the values again. So angle Q is equal to 6y plus 7. Y is 6.5, so that's 6 times 6.5 plus 7. If I evaluate this, that's going to give me angle Q being equal to 46 degrees. Angle R is 15x minus 6. 15 times instead of x, I'm going to put 10. Take away 6. 15 times 10 minus the 6 gives me 134 degrees, which is going to be equal to angle R. Last one, angle S is 8y minus 6. Substitute 6.5 for y. Gives me 8 times 6.5 minus 6. The 8 times the 6.5, take away the 6, gives me 46. Oops, sorry, put equals. Alright, so angle Q plus angle R, if I were to add those two together, I get 180 degrees, which makes these two supplementary. And then again, if I add angle R plus angle S, I also get 180 degrees, which makes these two supplementary. So because I have consecutive angles being supplementary, I know that this is a parallelogram. Alright, so now we need to determine if the quadrilaterals must be a parallelogram, and then we just need to justify our answer. So I have 107 and 73 being consecutive angles. 107 plus 73 gives me 180 degrees. And then the same can be said for this side. 107 plus 73 gives me 180. So that means yes, that's a parallelogram. Now this one here says that these two opposite sides, opposite angles are congruent, but it doesn't say that these two opposite angles are congruent. And the theorem said that both pairs of opposite angles needed to be congruent, so this is not enough information because we only are given one pair of opposite angles to be congruent. So now we're being asked to show that the quadrilateral JKLM is a parallelogram by using the definition of parallelograms, and then we have a series of points. For me, it would be helpful just to see kind of what this is going to look like. So I'm assuming that it's a parallelogram, and I'm going to label JKLM. That might not be where it is. I didn't plot any points. I just needed to know which sides were going to be opposite each other. So now I'm going to check to see if JK and LM have the same slope, because if they have the same slope, then that means that they're parallel. So first I'm looking for the slope of JK, and that's going to be, you guys are going to have to go back and look up your point slope, or your slope formulas. You have the change in y over the change in x, so I'm going to get the values for j and the values for k, and I'm going to find the difference in the y's over the difference in the x's. So that's -1 minus a -6 over a -4 minus a -1, and that's going to equal a -5/3. Slope for LM, same thing. I'm going to find the difference in the y's over the difference in the x's. So now I'm looking at point L and point M. The change in the y's is 0, take away 5, and the change in the x's is 7 minus 4, and that's going to give me again a -5/3. So it's looking good for a parallelogram. I know that these two sides are parallel. Now I need to check KL and JM. I have my slope for JM. I'm going to use point J and point M. Same thing, find the change in the y over the change in the x. So that's going to give me 0 minus a -6 over 7 minus a -1, which gives me 6 over 8, which I can reduce to 3/4. Then I need to find the slope for KL. Change in y over change in x, so that's 5 minus a -1 over 4 minus a -4, which is equal to 6 over 8, which again I can reduce to 3/4. Because my slopes are the same, I know that both pairs of opposite sides are parallel, so I know that yes, this is going to be a parallelogram because the opposite sides are parallel. the next problem. We need to show that the quadrilateral is a parallelogram by using, and they specifically wanted us to use theorem 631. So if you go back either in your notes or if you rewind the video, or you could just wait for me to tell you, but 631 said that the opposite sides were parallel and congruent. So we need to find a pair of opposite sides, and we need to show that they are both parallel and congruent. So we have, again, I'm going to just draw a parallelogram in the corner so I know what I'm looking at. And it says AB, CD. That might not be what it looks like when I graph it, but that's kind of the idea of what I'm dealing with. So I have AB and CD, which are opposite sides. I'm going to try and prove that they're both parallel and the same distance, or that the sides are congruent. So I'm going to start with the slope of AB, which again is going to be the change in y over the change in x. So we've got 2 minus 3 over 6 minus 2, which is going to give me a negative 1/4. And then the slope of CD, which is 1 minus 0 over 1 minus 5, which is again a negative 1/4. So our opposite sides are parallel. Now we need to prove that they're congruent. To prove that they're congruent, we're going to use our distance formula. So the distance for AB is going to be the square root of 6 minus 2 squared plus 2 minus 3 squared. That's going to end up giving me the square root of 17. Now to find the distance of CD, again using the distance formula, I have 1 minus 5 squared plus 1 take away 0 squared, and that is going to end up giving me the square root of 17. So since both of these are the same distance and they were both parallel, I know that these shapes that are created are parallelograms because opposite sides are parallel and congruent. This is the last thing I need you to know. When you are trying to prove something is a parallelogram, you only need one of these things to be satisfied. So you learned 5 different theorems today. If one of these works, then you know that you have a parallelogram. Or you can also go by the definition of a parallelogram, which says that both pairs of opposite sides are parallel. If you have any questions, please make sure you write them at the bottom of your notes. Don't forget to submit your summary in Edmodo.